Welcome all to today's talk on analytics in cricket. Thank you for attending and making the talk even more lively. So before introducing our star speaker for the day, I would like to take a bit to talk about our brand new program. I'm sure Hari sir will also be talking about it, MATH.BIZ. So MATH.BIZ is a 10-day residential camp on applied math, organized free of cost for participants. The program focuses on relating high school math with various fields like economics, accounting, finance, and operations management. Math.biz is going to be held at Mahindra University, Hyderabad, between the 19th and 28th of June. So if you keep asking your teacher why is trigonometry and calculus useful when it is being taught at school, and you're not happy with the answers that you get, then this is the camp for you. So please check out the link in the chat. I'll post the link to register soon. So with that said, I'm really glad in getting the opportunity to introduce the speaker, Hari sir, today. He's a faculty in managerial accounting at the Frankfurt School of Finance and Management. He finished his PhD in accounting from Michigan State University in 2021 with papers in various top journals like Journals of Accounting and Economics. He's also a chartered accountant. He obtained an international rank 1 in the Certified Management Accountant exam, which is the equivalent of the chartered accountant in the United States. He's also one of the co-founders of the Raising a Mathematician Foundation, which is organizing this talk. And he's a really passionate educator. The Institute of Chartered Accountants of India has recognized his contribution to the field of education through various awards. So he has been an amazing inspiration to a lot of students at the RAM Foundation, including myself, and a fantastic mentor. In fact, he's one of the biggest reasons why I ended up mixing economics in my research. Apart from his academic achievements, he's also an ICC certified cricket coach, and he finished an umpiring course when he was just 18. He's also an amazing chess player. Last year, he did a talk on analyzing gender differences in chess using high school statistics. This time it is going to be stats in cricket. Over to you, sir. Looking forward to the talk now.
Thank you, Adityan, for that generous introduction. And good morning, good afternoon, good evening to everyone from wherever you have joined the talk. It's so nice to see so many people interested in learning about math and looking at applications in domains which normally we don't get introduced in school curriculum. So without much ado, let me jump into this session for the day. So let me share my screen. Okay, Adityan, is my screen visible on?
Yes, I can.
Full in the presentation.
Yeah, it is
mode,
right? Right.
Okay, so today we are going to talk about data analytics in cricket. So how data analytics is can be used in many capacities, right? Either in a formal capacity where you want to analyze the game, maybe you are a part of the team, or you are working as a professional for any organization that is into providing some kind of entertainment and helping the audience understand the game better. Or you can be someone like me who is passionate about the game and is just interested in statistics and wants to look at areas where you can apply statistics. So I see this more of a session on statistics than on cricket. So cricket is just an area where this can be applied. You can think of how statistics can be applied in areas where you are interested. So it need not be cricket, right? That's why it was clearly mentioned in the flyer that you don't need any prior knowledge of cricket. So that's the caveat with which I wanted to start the session. At any point of time, if you have any questions or if you have any comments, please feel free to raise your hand. Use the raise hand option in Zoom, and Adityan will monitor the chat, and we can have a discussion. What I request you all is to not unmute yourself and directly start talking, because in Zoom it might be difficult to monitor, or it might be difficult to have a discussion that way. So just use the raise hand option, and we will ensure that we have a discussion on anything that you want to talk about on this topic. So this is the agenda for today's session. So the plan is that I will talk for maybe 45 minutes to an hour, uh, and then we will open the floor for questions, and we will go on from there. So first, I want to discuss the concepts of arithmetic mean and standard deviation, because these two are the basic concepts in statistics, which I think gets introduced at a fairly early stage in your life. So in schools, you would be talking about arithmetic mean. I think you start talking about arithmetic mean in 7th grade, and then you also talk about standard deviation probably in 8th grade or maybe 9th grade. So today we'll talk a little bit about those two concepts in from a measurement perspective and also interpretation. Measurement is something that you get introduced in school, but I think a lot of people may not be that comfortable when it comes to interpretation. So we will also talk about how to interpret these two measures. Uh, and then we will briefly discuss how these ideas can be used to measure performance. And we will look at data from cricket to explain this particular phenomena. But let me remind you that the same concepts can also be used in little more in domains which are even more involved in terms of analysis as well. Already I'm going to make it very simple in terms of where I am applying this ideas, because it can get quite complicated very quickly if you start looking at cricket itself, because the game is complex and it's very difficult to absorb these ideas in simple measures like arithmetic mean and standard deviation. And there has been a constant evolution of how data analytics is used in cricket and is helping teams to perform better. And finally, we will give a little bit of structure to this session in terms of from instructional viewpoint. How do you do data analytics in general? So we will start with specific idea of data analytics in cricket, and then we will try to provide a framework of how to approach any data analytics problem. So first, let us talk about arithmetic mean and standard deviation. So before we jump into it, I just want to know where we are in terms of understanding these ideas. So can someone explain what arithmetic mean is and how do we measure arithmetic mean? Just use the
Sir,
okay.
arithmetic mean means average.
Can you elaborate a little bit more?
So I'm
Sir,
raising my hand.
sum of the values divided by total number of values.
Okay, very good. Yes, Sureka.
That's actually my parents' account. My name is Ayush.
Ayush,
Uh,
okay, Ayush. Can you, is it
I'm
possible for
actually
you to rename yourself? That will be better so that,
yes.
yeah,
Anyway,
yeah.
I'm actually in fifth grade, and they teach these concepts in fourth grade actually in my school.
Oh, very nice. Okay.
So there are actually three different types of mean. Of there's mean, median, and mode, and all
Mhm.
of them are caused by are called average because statistics is confusing. But you should ideally call them by their names mean, median, mode. So Mr. Soham already gave an explanation of what mean is. Medium is basically median is basically the middle value, as in the medium is the value that is halfway inside your data set. The mode is the value which is the highest. So I feel the mode is quite useless in cricket analysis, simply because you will hit ones randomly according to some distribution. Mode would be quite useless in cricket, but medium is actually quite useful compared to mean, because if a bad player somehow scores a century, then his mean will go skyrocketing, but his median will only go up by a tiny bit. So median is more level-headed and doesn't care about outliers. Same thing if
Okay.
KL Rahul sometimes gets ducks a lot. KL, but so his batting average is effective. His median isn't.
Mm. Great. Okay. So we have three types of averages: mean, median, mode. And as you correctly pointed out, statistics is confusing. So they give the same terminology to three different concepts. And within mean also, you have three types of mean. So you have something called as arithmetic mean, you have geometric mean, and you have harmonic mean. But today we are only going to focus on this.
So the arithmetic mean is just dividing the sum of everything by the total number of things. The geometric mean is the root of the total number of things of the product of all the things. So if you have three values A, B, and C, AM would be A plus B plus C by 3. GM would be the cube root of ABC.
So AM is A plus B plus C by 3, and GM would be cube root of A times B times C. Okay, excellent. We'll not talk about harmonic mean. If you want to learn a little bit more about arithmetic mean, geometric mean, that we will do in MATH.BIZ. But some of you might be aware that arithmetic mean is always greater than geometric mean. And I mean, arithmetic mean can be equal to geometric mean when all the values are equal. So if you consider A equal to B equal to C, you will see that arithmetic mean equal to geometric mean. Median, as Ayush pointed out, is a measure which divides the data into two equal parts. So 50% of the data is to its left, 50% of the data is to its right. And he also mentioned that median doesn't get affected by extreme values, but arithmetic mean does get affected by extreme values. So if you score a lot of runs in one particular innings, your arithmetic mean can fluctuate, but median is not affected by extreme values because it just takes the centermost value. So if the extreme value is 1,000 or if the extreme value is 1 million, it doesn't matter as far as median is concerned because it's just looking at the centermost value. Mode is the number which repeats maximum number of times, and actually mode also gets used in cricket. It's not that mode doesn't get used, but as Ayush pointed out, it has limited utility in terms of evaluations. But mode does get used. Can someone? So mode is a number. Mode is a value which repeats maximum number of
I
times.
think there's only one specific area where mode might be useful in cricket. Only one.
Oh, okay.
Which
Ayush,
I believe.
hold on. Wait. Hold on. Let us try and ask others. You hold on to your thought for a minute. Let's see if someone else has anything to add. Where do you think that mode is getting used in cricket? Or anywhere else? Anywhere else?
Mode can actually be used to replace null data sets, as running null data sets will void the program. So if we take the most common value in a program or the highest value in a program, we can effectively elude that and the program won't crash at the beginning.
Okay.
So, and mode can be used in KBC, where if someone doesn't know the answer, he chooses
Ah,
the public opinion, then he'll choose the mode.
okay. So that's a good point. That's a much more simpler point than what Mahir identified, because not
Sir, can
everyone
I
might
give?
be aware of. No,
Sir,
no,
can
wait, Ayush, just wait. Because I know that you understand, I would just want to gauge what others are thinking, so that we can have everyone involved. So you have given excellent explanations of all the concepts. So kudos to that. What else? So this is a very nice idea, right? I am participant in KBC, and I don't know, and I'm assuming that everyone knows about this program called Kaun Banega Crorepati. So it's just like a quiz program, right? You have 4 options. You have to select the answer, the correct answer, but you may not know a correct answer, and there is an audience poll possible. So once you have the poll results, what do you go? You don't take the mean, right? Mean doesn't mean anything in that case. Actually, mean is useless over there. Do you use mode? So you know that A is answered by what percentage of the audience, B is answered by what percentage of the audience, C is answered by what percentage of the audience, and D is answered by what percentage of the audience. So you want to know which option has been selected the maximum number of times, and that's where it's useful. Anyone else? Yes, Nandika.
Like I just know badminton. So in badminton, sometimes they'll show statistics, and a smash is basically a power stroke. And for a player, they'll notice how many times they smash in the leftmost corner or rightmost corner of the court. And depending on that number, you can form strategies to avoid your opponent smashing.
Okay. So again, you are trying to find out how many times have they smashed in the left, and how many times have they smashed in the right, and then you can design strategy on how to tackle that. So again, you are looking at the mode to understand this. Very good, very
sir,
good.
please, can I give an answer?
Are you sure? No, you will have to hold on to your thought. Wait. Uh, because there are others as well who want to answer. Okay. In fact, there is a very nice paper in economics on penalty kicks in soccer. So there is this paper that came out in 2002, where they have analyzed what kind of strategies do the strikers use when there is a penalty shootout. So they looked at all games that involved penalty shootouts, and they tried to find out what is the kind of strategy. Do people hit to the left of the goalpost, or do they hit to the right of the goalpost, or do they strike in the middle of the goalpost? So it's very much similar to what Nandika mentioned about badminton, and trying to use the left and the right of the court. Yes, Jonathan.
Yes, sir. So in cricket, it can be used like to see which way a batsman has hit, so you can install fielders to get him caught out.
Okay, so you're trying to find out batters where they hit the ball, and where does the ball go. So there is a change in the terminology that ICC uses. So now it's not called batsman, it's called a batter. Okay, so please be aware of the terminology that is getting used, because batsman is gender specific, whereas the batter is gender neutral. So you may want to be careful in using these terminologies. Like we don't call bowlman, right? We call bowler. So bowler is gender neutral. So similar to that, batter is a gender neutral terminology. So please be aware of that the terminology itself has been changed in ICC cricket rules itself. So that's a recent change that happened, I think, couple of months back. So just putting it out there so that we can use those terminology. I mean, it's just out of habit, right? I mean, last year I also was struggling to say batter, because I've been so used to using this terminology batsman, but with practice it comes to you naturally then. Yes, Krishna.
Yes, sir. So according to me, mode can also be used in the field of marketing, sir. Like, what is the feature that most of the customers prefer over a particular product? So marketers can analyze this data and make the required changes in the product. So, for example, if you take the automobile industry, the demand for electrical cars are being picked up at very fast rate. But also many news that most of the electric cars get burned out and such stuff. So many marketers are like what to say, they are looking for an opportunity to utilize this demand for electric cars and make the required changes uh, to make it as a uh, best alternative for petrol or any diesel cars.
Mm. Excellent, excellent. So this will help you to decide how much resources you want to allocate for producing a particular type of a product. So again, mode has utility. Who else? Dikshant?
Yes, sir. Sir, I wanted to add that in cricket, you can analyze the overs in which a bowler takes wickets, and then you find the mode of it. So you get the that the bowler is more effective in this over range. So you give him the ball during that time.
Excellent. So you can also analyze past data and look at what are the overs in which the bowler has been most successful and try to strategize accordingly. In fact, this was used in 2011 Cricket World Cup, where India won that Cricket World Cup. And in that, if you go back and see the matches, you will see that one of our most successful bowlers in that tournament was Zahir Khan. And Zahir Khan took a lot of wickets when he came back to bowl somewhere in the range of overs number 38 to 43 types. And that was based on an analysis that was done by the statistical analysts in the team. And they said that Zahir Khan has been bowling really well with the old ball. So there is some. So when a new inning starts, you get a new ball to bowl, and there are advantages of bowling with the new ball, but there are advantages to bowling with an old ball as well. This is a little bit of technical aspects, but most importantly, statistics was used, which helped the team India to realize that Zahir Khan was most effective in overs in certain uh, frame of time in terms of overs, and they decided to bowl him during that time, and that helped the team tremendously during the
Sir,
2011 World Cup.
sir, please
Yes,
come.
yes, Ayush.
So I cannot believe no one has yet thought about this. The mode of how many runs a batter scores in a ball. How has no one thought of this? If a batter scores equal number of dots and sixes, then according to the mean, he scores an average of three runs a ball. According to the median, he also scores an average of 3 runs a ball. But he has never scored a tree in his entire life. So mode would be easier here because instead of saying on average he scores 3 runs a ball, we can say he most commonly scores dots and sixes in a ball.
Correct. Right. So, so that's a good point that sometimes you will get average which is not at all represented in the data. I mean, you don't see the mean value in the data itself. You don't see the median value in the data itself. So that's a fair point. But that necessarily doesn't mean that it's of less utility, but that's a limitation that you should be aware of. That's a good point. Once again, Ranjit.
Hello, sir. My name is
Yes,
Ranjita actually. I really
Ranjita. Okay.
respect your feminist ideas. Thanks for shifting from batsman to batter. So, sir, you could use statistics depending on the weather conditions to where to bowl the ball. Suppose it's a humid condition, then yeah, Yorker is bouncer is not very preferred as the bounce won't come properly.
Mm.
So, depending on the statistic, the weather data, you could.
Very good, very good. So you can use statistics and combine it with weather data, and then try to apply where do you want to bowl. And a lot of things have changed, right? I mean, there is so much data now available that you can create strategies for each individual batter and try to find out where to bowl. And there are specialists in the team who do that. You don't have to be a player to be doing it. I mean, it takes a lot of important time from your practice or your peace of mind. So you don't want to do this. You want specialists who can do this, and you don't need to be a cricketer to do this analysis, right? So that's another advantage of knowing cricket, but at the same time knowing statistics. Vishal.
Sir, could you please explain HM?
Harmonic mean. So we are not talking about harmonic mean. I don't want to deviate much from our topic. So we are not going to talk about harmonic mean.
Thank you, sir.
Okay, so this is about average. Now let us talk a little bit about standard deviation. So how do you compute standard deviation? Does anyone have an idea of computation of standard deviation?
I have a question, and I know how to compute standard deviation, but first I have a question.
Yes, Ayush.
There are many distributions in statistics: normal, binomial, Poisson. So what distribution? So what distribution does a batter's batting averages in an inning usually follow?
Batter's batting average, what distribution does it follow?
No, how many runs a batter scores in an inning? What distribution does it follow? Because if we knew that, and we knew his mean, arithmetic mean, and we knew his standard deviation, we can predict the probability of the batter scoring this many runs in an inning, which would be awesome.
Yes, that's a good point. And that is little scope out of the scope of today's session. So, but maybe I will show you the distribution of runs, and then you can take a guess what kind of a distribution is it. Okay, so we will not talk about distributions today because that's a little more advanced topic. Okay, so how do we calculate standard deviation?
Sir, standard deviation is the square root of the average of squares of the deviation from the mean values.
Okay, so okay, standard deviation.
Can I elaborate on Mr. Dikshat's point?
Yes, I think it was Soham, but yes, go ahead. Wait,
So
first, 1 second. Just let me write down what Soham just said. He said, take the first value, subtract the average, square it. Take the second value. So x1 is the first value in the data. Take the second value, subtract it from the mean. Take the third value.
X1 or X2, you can just use sigma and do cover everything.
Yeah. Divided by 3, and then you take the square root over all this. Okay.
So my elaboration was that the entire thing inside the square root, that is called the variance. And the square root and the square root of the variance is the standard deviation. The square of the standard deviation is the variance. And also the reason that we square all the values and then take the square root on the outside is because the reason we do that is because if we just take the difference of all the values, half of them are negative and half of them are positive. So it turns out that always it will cancel each other out. So I have to square it to make everything positive, and then we have to do the square root at the end to cancel it out.
Very good. Very good. So if you don't square these differences, then if you add all the differences, you will get 0. And so the squaring is a way of doing something called as you're weighting the differences. So first thing is you're doing x1 minus x bar, x2 minus x bar, x3 minus x bar. So what you're trying to do is you're trying to find out how much is the deviation from the arithmetic mean. Okay, so how much are you deviating from the mean? The larger that you deviate, the higher will be the standard deviation. And by squaring, you are actually penalizing large deviation. So if the deviation is 5, squaring it makes it 25. If the deviation is minus 5, by squaring it, it becomes 25. So you don't distinguish between a positive deviation and a negative deviation. You just say that, okay, it's a deviation. You should have, if you had no deviation, that means every single time you just scored the average. You just scored equal to x bar. So if you think of x1 equal to x bar, x2 equal to x bar, and x3 equal to x bar, that's the ideal measure. Standard deviation would be 0. But in all other cases, the standard deviation will be greater than 0. And note that standard deviation is the positive square root of whatever is there inside the square root. Okay, it's not plus or minus, it's just a positive square root. Now in this, when you square, the problem that happens is your unit of measurement. So think of x1 as runs, right? X bar is also runs. So when you do runs minus runs, that's also runs. I mean, you will get the unit of measurement as runs. And when you square it, you get a weird unit of measurement, run square. So you will get run square from the first parenthesis, you will get run square from the second parenthesis, in the third also you will get run square. But there is no meaning of a number like 17 run square. And that's why when you finally take the square root, the unit of measurement goes back to runs. So it's easier to interpret the unit of measurement when you take the standard deviation. It's not interpretable without the square root, which Ayush mentioned, that if you take the square of the standard deviation, you get something called as the variance of the measure. Yes, Ayush? Is your raise hand from the previous point? Okay.
Yes, sir. So I just have a question. What's stopping you from the absolute value x1 minus x bar plus the absolute value of x2 minus x bar plus the absolute value of x3 minus x bar divided by 3?
So nothing stops you. So that is called as mean deviation. So that is the average of the deviations from the arithmetic mean, because you are taking the deviations and then you are taking the average. Like Soham mentioned, this is a different measure, and that is called as the sum of the squared deviations. And again, this is also a mean, right? This is the mean of the squared deviations, and then you take the square root of that. So what you are mentioning is a different way of computing the deviations, but you can't call it standard deviation because that's calculated slightly differently. There is a name for that.
But got it.
So then you can, I mean, a little more advanced question is what is an ideal measure for doing that absolute deviation? Is mean better or is median better? Why is mean better here than median? Those are some advanced level questions that you can think of, or maybe if you participate in MATH.BIZ, you will get to know a bit more on why only mean is used for computing standard deviation? Why mean is a better way to better use of the standard deviation? Okay. So just a quick question. Is lower standard deviation good or is higher standard deviation good? Would you prefer standard deviation to be small or would you prefer the standard deviation to be large? Would you prefer the standard deviation to be large or would you prefer the standard deviation to be small?
If you're aiming at consistency, you want the deviation to be small.
If you if you want the what did you say? Say
you
that
want
again.
consistency, you have to aim at the deviation being small.
If you aim at consistency, you want the deviation to be small, right? I mean, if you want to study consistently, what does it mean to study consistently? Is to ensure that you're putting more or less equal effort across multiple days. So there will be less deviation or less variance in how you are spending your time. Okay, so that's very good. Yes, Vishal.
I think it would be large. Standard deviation should be large.
Why do you say that?
Because you're taking the root of the variance.
No, I'm not saying whether the standard deviation, what will you prefer? Do you prefer standard deviation being large or do you prefer standard deviation being small? What is your preference? Let me ask you another a different question. Would you like your average to be high or would you like your average to be small, assuming that higher numbers are good? So think about your marks in the exam, and then you take the average of the marks obtained in all subjects. Would you prefer your average to be high or would you prefer your average to be low? Vishal?
I would prefer to be higher.
Okay, you prefer to be higher. Now, you also compute the standard deviation of all the marks that you have obtained. So for all the marks, you calculate the average, you take the standard deviation. Now, you have two students, student A and B, who have the same mean. Now they have different standard deviation. One student has a high standard deviation and another student has a low standard deviation. What does it mean to see a high standard deviation compared to low standard deviation? What do you think? What is
That
the
means
interpretation?
their marks differ more if they have a higher deviation.
Sorry?
If they have a higher deviation, that means they differ more. It's inconsistent.
They differ more. It means that, what does it mean? Okay, let me ask Farish. Farish?
Yeah.
Farish, you're on mute.
Yeah, I think it depends on context. If you want more randomness, then a higher standard deviation would be beneficial. For example, in the context of the penalty taking, if you divide areas into numbers, you'd want it to be more random and unpredictable. So you'll want standard deviation to be greater so that the opponent cannot predict what you're doing. But as a mathematical point of view, if you want to predict an output, if you want to find out what will be the average of this, what will be the output of this, in order to predict, you would want standard deviation to be low, because that restricts you and that will give you more accuracy, because that shows that values in the output range in a smaller area, and therefore you're more likely to be accurate in predicting. However, it depends on the context. If you want randomness, you'll want a higher standard deviation.
Excellent, excellent. Very good. Very good. Yes, Mihir, what so based on what Vishal just mentioned, it talked about randomness, which might be good because you don't want to be predictable. But if you want to predict, you want lower standard deviation, because there you will have more confidence in your prediction or estimation. So Mir, just a quick question. So let's say you have marks and you're computing standard deviation and you get two students. One student has high standard deviation and another student has low standard deviation. What does it mean? What is the interpretation that comes to your mind?
So there can be many interpretations. One can be for example, if the student is getting high marks in sciences and maths, it means that the student might aspire to become an engineer, and science and math is his or her field. While if a student is getting a low standard deviation, maybe they are not as interested in a particular subject. They just want to get good marks so that they can pursue a career later in life.
Okay, so
They are
lower,
undecided.
I this interpretation, I mean, this is fine, this is good, but this is slightly difficult to interpret. But what you are saying, I'm going to use some part of it, that when you have low standard deviation, it's likely that you have scored more or less equal marks in all subjects. I mean, I'm using the term equal in a very loose manner. But if you have high standard deviation, means that there are subjects where you have scored very high marks and there are subjects where you have scored low marks. That's why you have a high standard deviation. You can't have a high standard deviation if you have scored consistently across all. So again and again, we are using this word consistency, consistent, and then we are talking about standard deviation. Okay, so let us quickly jump to the second part of the topic, which is to look at performance metrics that are used in cricket. Okay, so common metrics that are used in cricket. So it started with, this is the timeline. I will share the slide deck with you all. So I will quickly talk about, how cricket statistics was used first in 1890s, then in 1960s with the use of computer analysis became easier. 1980, new metrics were included, like batting average, how many runs were scored divided by the number of innings or number of matches in which a batter gets out. Bowling average is how many wickets have you taken based on how many runs you have given. So bowling average, lower bowling average is better, because as a bowler, you want to take more wickets and give fewer runs. As a batter, you want to score maximum number of runs, right? Strike rate is again how many runs do you score per 100 balls faced. So the strike rate is computed like a percentage. 1990s, more advanced metrics, because that's when, one day international cricket became popular and people started to look at much more sophisticated metrics, win percentage and all. And now we as you all may be aware, when you watch cricket, it's getting more and more sophisticated. So there is a data driven revolution. So now you want to analyze data, and so that you can strategize and help cricketers and teams in unlocking the potential. So and I mean, it's not a secret in India that cricket is one of the most popular sport, and around the world as well, and it's gaining more
You,
popularity
you
now.
mentioned that ODIs became popular in the 1980s. In fact, basically, India invented modern style ODIs in 1980s. Basically, India wanted to host 1987 World Cup. ODIs back then were 60 overs, but they didn't have enough time to hold 60 over matches. So they said, who cares? Let's make ODIs 50 overs from now on. So they were basically invented in the 1980s, basically.
Correct. Except for the fact that it was not India who said that it should be 50 overs. It was the International Cricket Council that decided that it will be
But that was because, but
50
that's
overs.
because India pressured them to.
Sorry?
But that was because India had to do it for them to get the hosting rights.
Okay. Okay, very good. So, okay, so the game has evolved, game has changed, and there is more data available. We have more better techniques available to analyze this data. We have, and today I'm going to talk about two batters who have already retired. and I wanted to analyze two cricketers who have been phenomenal cricketers for India, and but they have completely different styles. And I'm only going to talk about test match cricket. So this is a word cloud that I created for a batter named Rahul Dravid. Rahul Dravid is the current coach of the Indian cricket team. And one terminology that gets used again and again for this batter is this term called consistent. Apart from that, he's called uh, uh, the wall, dependable, legend, etc. But he is called by this term consistent. Now it is very interesting because when I was growing up, this is in 2001, 2004 types, when I was in college. That time, you will hear a lot of commentators who are commenting on the game say that, oh, Rahul Dravid is such a consistent batter, but they would never say why do they say what they say. So there was no metric that would corroborate the story that he's consistent, right? And then there was another batter, Virender Sehwag, again a legend of the game, excellent cricketer, phenomenal record in test match cricket. Test match cricket is a cricket played over 5 days, and those are the technicalities, but it's one type of cricket game played. But you will see that he's called everything but consistent. So there was no one who would call Virender Sehwag consistent, right? He would be called attacking, fearless, powerful, impactful, explosive, but his style was such that he was never consistent. So what made experts call Rahul Dravid consistent? Right? So what is the criteria that we can use to call a player consistent? And how are we going to measure consistency more in general, right? So the first one is, why is Rahul Dravid called consistent? Second is, what is the criteria that we can use to call a player consistent? And the third is, how do we measure consistency? So the third one is much more general question. So if we look at the runs scored by Rahul Dravid and Virender Sehwag over their career, this is how the distribution of runs looks like. So the red is the number of runs scored by Sehwag in each inning that he went on to play in a test match. So typically in a test match, it's 2 innings per side. And on the x-axis, it's the innings number. So innings number 1, how much they scored, innings number 2, how much they scored, and so on and so forth. There will also be gaps in the bars. So actually the gaps after the red mark finishes is because Sehwag had already finished playing all the matches, and Dravid went on to play more number of matches than Sehwag did. And on the y-axis, you have the number of runs scored in by the batter. Okay. So if you look at Virender Sehwag's batting stats and Rahul Dravid's batting stats, you will notice that their average is quite similar. So on average, Rahul Dravid scores 52.31 runs per innings. So every time he goes on to bat, he scores 52.31. Now, this is very easy to compute. You take the total runs, but ensure that you are not dividing by the total number of innings, because out of 286, 32 times he has remained not out. So you don't include the not out innings, because in that not out innings, the batter did not get the full opportunity to play, and therefore you have to deduct 32 from 286. So that will be 286 minus 32. That will be the denominator to compute the average. So when we say average here, it is the batting average. Sorry, it is the arithmetic mean that we are talking about. So as you see, Rahul Dravid played 286 innings in his life, and Virender Sehwag played 180 innings in his life. One of the things that you should understand is that when you are computing average, you want a larger denominator. You want more number of innings or matches. Only for few innings, your average may not be a good representation of the data. So what does average do? Average is kind of a one number that you can replace. So you can loosely say that Rahul Dravid scored 52.31 runs in every inning he went out to bat. Virender Sehwag scored 49.34 runs every time he went on to bat. This is on average how much they scored. But this says nothing about who was more consistent. More or less, you can see that if you look at the red graph is highly volatile. There are a lot of runs which have high, very large numbers, but the average is not that high, in the sense that the four red marks that I have circled, the average is not closer to that. Average is much smaller. That is because he also has a lot of runs in this vicinity. But Rahul Dravid's scores are more or less, less volatile. So this is a very crude way of saying that, okay, Rahul Dravid is more consistent. But comparing Rahul Dravid with Sehwag is much easier. It will be difficult to compare batters who are where the distribution is quite similar. So we need a metric. So what I am doing now is also computing the standard deviation. So if you look at standard deviation of Virender Sehwag, the standard deviation is much higher than the standard deviation of Rahul Dravid. So standard deviation is computed the same way as I mentioned how standard deviation is computed. So what I have done in this graphs is I have included the innings number on the x-axis, and on the y-axis now I am plotting the batting average. The blue is the batting average. So after every match, how did their average change? So as you can see that in the initial time period, the batting average is quite volatile, and the standard deviation is also volatile. So it is not meaningful to look at averages in a short period. You will have to look at a longer period to talk about average and standard deviation. But as you see, Rahul Dravid's batting average has been higher than his standard deviation across the throughout the career. Whereas Virender Sehwag's standard deviation is higher than the average. So more or less, Virender Sehwag has a higher standard deviation, which means Virender Sehwag is much more unpredictable than Rahul Dravid is. So if you want to make sense of standard deviation, you will have to compare two batters to make sense of what is going on as far as standard deviation is concerned. So that's the whole idea about how standard deviation can be used as a measure for comparing batters and trying to identify who is more consistent. But as I said, I mean, I have combined the two graphs, just it's the same stuff. RD is Rahul Dravid, VS is Virender Sehwag. It's very clear that Virender Sehwag had a higher standard deviation. But it is less obvious when you compare someone like Sachin Tendulkar and Rahul Dravid. In fact, Sachin Tendulkar and Rahul Dravid more or less have similar averages again, 53.78 and 52.31. But now if you start looking at their standard deviation, in fact, it turns out that Sachin Tendulkar's standard deviation is slightly lower than Rahul Dravid's standard deviation. In fact, I was talking with Adityan a few days back, and I was telling him, before I computed the standard deviation for Sachin Tendulkar and Rahul Dravid, I don't know what to expect before computing. I don't know if Sachin Tendulkar's standard deviation would be lower than Rahul Dravid's or higher than Rahul Dravid's. But if you see, commentators would not call Sachin Tendulkar, I mean, of course, he was consistent, but the term consistent was reserved for Rahul Dravid because probably there were many more accolades that they could use for Sachin Tendulkar. But at the same time, it clearly shows that Sachin Tendulkar's standard deviation is smaller than Rahul Dravid's standard deviation. So that's why it's important to use a statistical metric rather than using your intuition to just comment on what performance metric you are talking about. So consistency is a metric, but how do you measure that metric? That's the important takeaway from today's session. When you compare Dravid versus Sehwag, it's very obvious. I mean, Dravid is simply much more consistent than Sehwag is. And I think you could have said that just by looking at the distribution itself. You don't have to get into these computations, but the differences are quite small when it comes to comparing other batters. So you need a metric to evaluate that. I just looked at how Kohli and Sachin Tendulkar's graphs look like. So this is Virat Kohli's batting stats, and since he is still playing, I am mentioning that this is the data that I took on February 17th. So it doesn't include the third test match that India played against Australia. And as you can see that Virender Sehwag, with Virat Kohli, it looks quite similar to what Sachin Tendulkar's graphs look like. In fact, during this period, it has been a long time since Virat Kohli has scored a century. I think it's been more than 1200 days that he has not scored a century. So again, if you compare Virat Kohli with Sachin Tendulkar, it's not very clear who has a lower standard deviation, but once you compute it, it's clear that Sachin Tendulkar's standard deviation is smaller. In fact, the standard deviation is smaller than the average, whereas Virat Kohli's standard deviation has gone up in the recent years because he has not been doing well in test match cricket, and his average has fallen. He used to be, if you see, he used to be quite high in this time period. During this time period, his average was quite high, and it has fallen. So the point is, it's better to compute a metric and then conclude rather than just looking at data and following your intuition. I just made this so you can do a lot of cool stuff, right? So if you have some skills on coding, you can do a lot of cool stuff. So what I've done is I created a video where you can have runs on the x-axis, and on the y-axis you have the players and how their runs evolved over their career. So each innings I am plotting the runs, and so the total runs will be shown next to the bars. So if you see here, this is how after each innings their scores are increasing. So as you can see, Sehwag's scores are higher than other people at some point, and so you can create these kind of interesting graphs. This is, from communication perspective, this is quite cool, because this is basically taking out some 300 odd rows and combining it into one graph or one video like this. So if you see, Sehwag and Kohli have stopped because their career, that is the number of innings that they have played, whereas Sachin Tendulkar and Dravid played much more innings. Sorry, the video. Rahul Dravid also ended his career, and this is where it stops. So in the white, it shows the batting averages for each player. So at the end, I just put the batting average for each of the players. Okay, so towards the end, you will see that the white is just the batting average. So Dravid, Sehwag, I purposely included players who have similar averages to drive home the point that standard deviation is comparable, provided they have same average, right? If their averages itself is different, then standard deviation may not be informative. So now we are going on to talk about a very generic question. What is the framework that people use to do data analytics? So we will talk about this fact framework. This is something that I am borrowing from a course taught in University of Illinois Urbana-Champaign. There is a course on Coursera which they talk about data, where they talk about data analytics. So this is the fact framework. First, you frame a question. So frame a question. How do we measure consistency? Like in this case, the question that I framed was, how do we measure consistency? Then I said, okay, where do I want to measure this consistency? I said, okay, let's assemble the data. Let's use cricket as the basis. So I went to ESPN Cricinfo. I collected the data. I took a data innings by innings, and downloaded it to Excel, and then used a software to do this analysis. Basically, instead of what you do in school, you do it by hand. I'm doing it using software because we have large data now. Then you do the calculations like I did with computing the arithmetic mean, computing the standard deviation, computing the arithmetic mean after every match or after every innings. And then today was the results day. I was telling you all the results. I showed you the graph. So this is the usual framework that data analysts use. So starting with framing the question till you tell the results. So there is a small difference between data analysis and data analytics, although these terms are many times used interchangeably, but there are some similarities. At the same time, there are slight differences as well. So data analytics is a science of evaluating raw data to make outcomes from the data. So you start with looking at runs scored by each batter, and then you bring outcomes from that, whether who is more consistent, who has scored more runs on average, and things like that. So the idea of data analytics is to use larger data sets. So as you can see with cricket, you have so much data now available that you can even analyze data on a real-time basis, like it happens with LBW decisions, right? Leg before wicket decisions, where you can ask for a review, and decision review system where the third umpire will help the on-field umpire. So on-field umpires are now able to make more accurate decisions because of technology, because more data is now getting available. So they help you to carry raw data and find patterns to take out useful ideas from it. And data analytics is a much more wider term, and it includes numerous assorted sorts of data analysis. So a lot of things that you would call as data analysis is just done at a bigger scale. Okay. So this is about today's session. So this is the kind of stuff that we will be covering in this program called MATH.BIZ, which is a residential program for students from standards 9 to 12. This is happening in Mahindra University, as Adityan mentioned, and this is free of cost for the students, thanks to the generous contributions, or thanks to the generous support provided by Pravaha Foundation. And this will be happening from June 19 to June 28, 2023. We have our chief guest decided. We are fortunate to have Sanjaya Baru as the chief guest. He is the author, and he was the media specialist for the UPA government when it was in power from 2004 to 2014. He is the author of the book called The Accidental Prime Minister. So he wrote this book, and so he was very supportive of this idea, and he was kind enough to accept our invitation. In addition, we will also have the former Chief Economic Advisor of India, Dr. Krishnamurthy Subramanian, who is currently representing India at the International Monetary Fund in Washington, D.C. So he can't be in person, but he has accepted our invitation, and he will be joining us online, and will be the chief guest as well. So the idea of this program is to talk about application of math in business domains. So this is something that you don't do in school curriculums. In schools, you generally get exposed to application of math in physics. I don't know in what other areas do students get exposed these days, maybe biology, but nothing beyond that. So this is a unique program, and this is a kind of a program that is not offered anywhere in the world. So if you think of pure math programs for school kids, it's offered in many countries. It's also offered. So we have two programs which are more in the domain of uh, pure and applied maths, but we don't talk in detail about application of math in business domains. Like we have Raising a Mathematician training program under Raising a Mathematician Foundation, which is for the students in the age group of 13 to 15. And we have Epsilon India, which is for the students in the age group of 9 to 12. So there is an entrance test which will happen on April 2nd, and the results will be declared on April 15th. So based on that entrance exam, we will be selecting 100 students, 50 students in grade 9 and 10, which will be called as a junior batch, and grade 11 and 12 will be the senior batch. So for the senior batch, we will be covering calculus and how calculus gets applied in business domains. For 9th and 10th grade, we will be covering similar concepts, but maybe we will not use calculus, but we will be using, let's say, similarity of triangles to prove the same ideas. So using mathematics, so math is the base, but the application is in different areas. So the way I think of this program, it's more math program, but the application is in the business domain. So someone like Ayush, for example, who is in 5th grade, is welcome to apply to the program. There is a test, you apply for the test. So we will be happy to even take students who are not in grade 9, but are but have the necessary knowledge or necessary subject understanding to participate. Okay, with that, I thank you all for taking out time, and will be happy to take any questions that you may have at this point. Yes, Vishal.
So I have a question regarding the graphs you showed us.
Mm-hmm.
So, one of the graphs you showed us was the standard deviation and average over time for, yes, this one. So, over time, basically, as the innings increased, the time frame increased, right? So it was just showing like how the overall standard deviation with an increased time frame as you go along the graph. So is it possible, like, what if we just took the standard deviation and average for like a certain time frame, like 50 to 100, 100 to 150, 150 to 200? What result would we get?
So if you break down the between 0 and 50, between 50 and 100, you will have to recompute the standard deviation. With the average, it might be slightly easier just to look at the graph and see what is going on, but you will have to recompute them. But yes, that is another way to see in which time period was the batter most prolific, for example, right? So for example, if you see the portions where Sachin Tendulkar's average has actually skyrocketed, right? From here, he has gone up substantially during this period. So that is the time when Sachin Tendulkar was scoring very high runs. Otherwise, your average cannot increase, right? Your average can only increase if your runs are much more than the average. That is also the case for Kohli. He started low and he went here. From here, he went up, and then he also went up further, which clearly shows that. So you can do analysis by cutting down the number of innings into parts as well. Yes, Farish?
Thank you.
Sir, can you hear me?
Yes.
Sir, regarding the MATH.BIZ test, what questions will be asked for it? So like where do we study for it and what portions will it cover basically? What aspect of our knowledge?
Yeah, very good. So there will be only one test, whether it's for junior batch or senior batch. It will be based on the syllabus covered in NCERT textbook up to 10th grade. So
All
if you
right.
are in 9th grade, you have to still, there can be some questions which are from 10th grade, which you are expected to answer. But note that I am not claiming that the difficulty level will be similar to what is there in NCERT. I'm saying that the topics covered will be similar, will be the same as what you learned till 10th grade. So it doesn't mean that something that was covered in 7th grade cannot be asked. It can still be asked. Anything till 10th grade is a fair question. I mean, we will also share a couple of few mock questions on our website. So MATH.BIZ, around 15th March or something, we will share a few sample questions for you to understand what kind of questions to expect. But at the end of the day, it's going to be relative grading, right? I mean, we will select whoever has
Top 100,
performed
okay.
well on the test. So if it's difficult for you, it's difficult for everyone. It doesn't matter, right? So don't worry about the difficulty level. Just worry about that it will be till 10th grade. In what grade are you in, Farish?
I am in 11th right now.
Right. So whatever
But
you
I
have
have
covered
done the
till 10th grade.
IGCSE curriculum. I have done the Cambridge International Mathematics till 10th. So that's why I was asking.
Okay. I mean, I don't know what's the difference in terms of curriculum, but we just wanted to use a textbook which is easily available, right? Even if I'm in, and it has to be something that is standard across the country. I can't say that, okay, we are going to use state syllabus, because I don't know what's the difference in Maharashtra state board syllabus versus a Karnataka state board. So we have to do some kind of crude standardization. So that's the reason.
Yeah, that's
But
not
I
a
think
problem, sir.
it shouldn't be that much of a difference.
So I have one more question.
Yes.
Apart from math, where did you get the data for all of this from, and what software have you used to make this? Because I want to make it for like some other players, and if I have to make these graphs or like calculate consistency or like standard deviation for some other player, how do I do it?
So I just searched for their career stats, so which landed me to Cricinfo, and Cricinfo has a nice way to get the data on innings by innings, and from there I just downloaded it in Excel, and then I use Stata, because Stata is what I have been using for my research. So everything is done in Stata, but the problem with Stata is it's not free, right? So you can use any software, it should be still doable. I mean, you can do this in Excel as well if you really want to do it. The video is slightly difficult because Sachin Tendulkar, as you can see, has played 329 innings, right? And I mean, I think there are some innings where he did not bat as well. So there are 347 innings. So that video is creating 347 graphs. Plus, for the last graph where it is static, I created 25 more graphs. So there are around 375 graphs, individual graphs, which then combined together created like a video. So it's basically 375 graphs that you see in that 1 minute video. So that's a little bit more difficult in the sense that you will have to write a code which will go in loop and do the computations, and then you will have to use a software, something called as FFmpeg, which is a open source software to just stitch the videos, stitch the graphs together. I think that's not the most difficult part. That's easy once you know how to do the graphs in any. I mean, it's just a one-line code if you know the software. So you can do it on Python as well if you're aware of how to do it in Python.
All right.
But
Thank you so much.
there is an initial initial cost involved in learning any language, right? That's similar to learning any software. But once you have invested that cost, the incremental cost is pretty low. Once you have invested a lot of time, you can just scale it up, and you can do a lot of great stuff with this kind of knowledge of just coding. And it's a very useful skill, I would say.
Yes, got it. Thank you so much. I really love the session. And now, because of this, I'm planning to apply for MATH.BIZ now. Thank you so much.
Good. Looking forward to seeing you.
Thank you, sir. Bye bye.
Yes. Gangulappa, Swaminathan.
Sir, myself Gangulappa, Ranjita's father, sir.
Okay.
This
Yes.
top performers like Virat Kohli and Sachin Tendulkar, sir. How do their diet plans and food patterns affect their playing, sir? If they affect the playing, what type of food should you eat, sir? Daily diet plan.
I am not an expert in that area at all. My expertise is not in that area, so I would not. I don't know is the answer to that question. Are you specifically asking because Nandika plays badminton? Is that you're asking for that reason, or?
Sir, this diet plans and food patterns of top. So
Uh-huh.
what's your question? So what's your question, sir?
No, I don't know. That's what I'm saying. I don't know how do they affect players' outcomes. I don't know anything on that. Sorry.
It's okay, sir.
Yes, Nandika.
Sir, when people choose strategies while playing, is it good to not have a consistency the strategy use, like keep changing a strategy, or sticking to one strategy will help you a lot?
Correct. So that is different, right? That is different from what we are talking about consistency here. So you may have different strategies just to confuse the bowler, but that is different from what the outcome shows. This is based on outcome.
Yes, sir, I realize that. I realize that this is for like performance outcome, and the other one is how you're playing the field. But which is more preferable?
I think that will depend. That will depend on a lot of situation, a lot of different things, right? What situation you are in. It will depend on who your opponent is. Some opponents get rattled with a lot of inconsistencies in your strategy. Maybe there are some players who are well prepared to tackle, and then if you throw in something that they are not aware of, then that can rattle them, right? So what comes to my mind immediately is a one-day cricket match that was played between India and Australia in Nairobi. This is the ICC knockout trophy, which happened in 2000, and India was playing against Australia, Nairobi. India went to bat first. Australia won the toss. Glenn McGrath was bowling, at his best, and the pitch was damp. And Sachin Tendulkar and Sourav Ganguly went to bat, and they were completely dominated. And then Sachin Tendulkar decided that that's it. I want to play some unorthodox cricket shots. And then he rattled Glenn McGrath, because McGrath was not used to seeing Tendulkar play that kind of cricket. So those kind of things are possible, but that will require you to understand the game and then see what is happening and then react. So it was not planned, but it was decided at that time that this is the best strategy to use. So sometimes it can be a very good strategy to rattle the opponent, because the opponent is so methodical that you may want to mix it up.
And also about the test on April 2nd, how many minutes is it for, and from what time can you take it?
So there will be 22 questions, 2 hours. So 20 questions will be 1 point each, and 2 questions will be 5 points each, where you will have to explain your answer. And we will be assessing you for how you have explained that answer, if you deserve. So in total, it will be 30 points. 22 questions, 2 hours for the exam.
Like the timings are like, is it taken in the morning or
That we have not yet decided, but you will get more details on the website later on once there is more information on the timing and all.
thanks
So
for also.
keep an eye on website. Adityan has already shared the link on the chat, but maybe he has shared it again, so you can take a look at that as well.
This was very useful talk, so thank you.
Thank you. Krishna.
Sir, I just have one statement, sir. So can you tell me whether it's correct or wrong? Sir, if the difference between the change in the batting average and the standard deviation, if it is low, then that player has scored an abnormally high runs in that particular innings, sir.
If the change in batting average and the change in standard deviation, the difference is
low, then that player has scored an abnormally high runs in that particular innings.
That may or may not be true, right? Because so you are thinking about a situation where batting average has also changed and standard deviation has also changed a lot. So the difference is small. But it could also be the case that batting average did not change and standard deviation also did not change, and the difference is also quite small.
Yes, sir. That may also be true. But if that player has played a lot of innings, so I think that difference may also affect a lot.
Yes, that is true. That is true. But I don't think that is quite, it can be generalized.
Okay, sir. But I also have another doubt, sir.
Yeah.
For the initial question, like when you asked whether the low consistency is good or whether high consistency is good, someone had answered that it's all subjective to one another. So for some areas, high consistency may be good, and for some areas, low consistency may be good. So, for example, if we take in economics the GDP of a country, so that the per capita income of a household may be low, but the GDP of a country may be high. If we take the example of India itself, so India is somewhere around 6th place in world's GDP, but the per capita income is very low as compared to its high GDP. So what we can observe is that the difference between the richest person in India and the lowest person is too high, because there are many persons who are earning in billions. So there are even some persons who are earning very low. So whether to ask.
But
Sorry.
in that particular example, the reason is because India has a lot of people. If India's GDP was say $1.5 billion, there are 1.5 billion people in India. The per capita GDP will be $1. Does that mean that there's big inequality? No, it just means that India has a lot of people.
Yeah, India does have a lot of people, but the difference between the income of each of every person increases by the increase in number of people. So we can add to your point actually.
Yes. So what you are saying is that the standard deviation is likely to be higher in case of country like India, which has a very high GDP, but the per capita income is small, which means that there seems to be a lot of variance in the income levels of people. Is that what you're saying?
Yes, sir. So when the question comes with is this situation is good or bad, what we think is that what aspect we are talking about. For example, we have several economics such as capitalist economy, socialist economy. So if it is a capitalist economy, then it does seem to be good. But in this perspective of socialist economy, it's not really good situation. So whether drawing conclusion if the high variance is good or low variance is good, it all matters about what perspective we are talking about. So that's the point which I was about to say actually.
Okay, very good. That's a good point. I mean, it's a very big discussion on the type of economies, so we will not get into that. But overall, I think there is consensus even in capitalist among economists who favor capitalist economy, is that uh, they don't want a lot of variance in the income levels, or rather income inequality is bad for whichever it is, but it's a it's an important criteria in socialist economies than it is in capitalist economies. That I do agree. But I think there is consensus that both types of economies prefer low inequality over high inequality, for sure.
Yes, sir. Got it, sir. Thank you, sir.
Mihir?
Sir, so my basic question is that how important is data analytics in cricket? Like, if example Pakistan gets all of our data on all of our players and their playing style, how much would that impact the match, or how much does it impact the match if one country has a lot of data while other has none? So how much would that impact?
I think it would impact a lot, especially in today's times. In fact, if you see, a lot of cricketers and have strategies specific to a particular batter or particular bowler. So there is huge use of data in today's times, much more than what it has been in the past. So I do think that there is a lot of role. Even as a spectator, there is so much role for data analytics. If you have seen in today's times, the way cricket is shown is completely different, and it's much more enjoyable with all these stats. I mean, at least I used to enjoy seeing a lot of stats when I was watching cricket. When I was your age, I would love to see stats. Without that, I would feel, oh, this is not a good coverage of the cricket match. Having said that, I remember one instance, after Tendulkar retired, Sachin Tendulkar tweeted saying that, he remembers a person who was an employee at one of the Taj hotels in Chennai. And this is how he remembered. He was, Tendulkar, if you see some of his innings, many of his innings, he did not wear an elbow pad. Okay. But there used to be times when he used to play with elbow pad. And this guy who was working at Taj came to his room. I mean, he came to change his bed sheets, and he said to Sachin, if you don't mind, can I say something? And Sachin said, yes, please say. And he told that I have watched your innings where you play with your elbow pad very closely, and I observe that your bat doesn't come vertically when you are putting a elbow pad on. And Sachin was taken aback because not many people knew that was happening. Sachin knew that was happening, but he was just taken aback by someone who could point that out to him, and he was surprised by that. So, and I mean, that's the kind of analysis that can be done. So professional cricketers, professional players can do that. I mean, there are different ways by which they use data, right? Another example that comes to my mind is from tennis, where this American tennis player Andre Agassi playing against Boris Becker, the German the tennis player. You should watch this video. Andre Agassi talks about how he cracked Boris Becker's serve. Boris Becker's serve was just too good to handle at that time. But there was a unique way by which Andre Agassi could recognize which way the serve is going to go. If it is going to go towards the center of the court, or whether the serve will be wide. And that was based on, just before Boris Becker serve, he would twist his tongue to the side where he is going to serve. So if his tongue is to the left, the ball will go to the left. If his tongue is is to the right, it will go to the center of the code. And if the tongue is straight, then it will come to his body. So Andre, I guess he says that it was not difficult for me after that to know where the serve is going to come. But the difficult part was to determine when to use that data. So he said that he used that data only in critical situations where he is desperate to win a point. So you should also be clever to know when to ignore some of the data stuff. So you have data, but you should also know when to not use that data as well. So you should.
I actually heard that the Germans had a code called the Enigma code, and the British scientist Alan Turing had cracked the Enigma code, and they figured out where all the German warships and planes were going and how to attack them. But they did not use the data a lot of the time. And the reason was,
Excuse me, actually, I just have a class, so can I just ask a question and leave? So
Yes.
my question, what is the scope for a career in data science in cricket?
Data science in cricket, that is a very specialized field. So you may not want to decide as of now that you want to become a data analyst in cricket. I think these things are not planned by most of the people. They would just want to become data analyst, and then if things turn out to be that way, then you become a specialist in cricket. But the skill set can be applied everywhere. So I would suggest to look up data science and data analyst courses rather than just specifically thinking about one area.
Answer one more thing. Do you think that AI will ever become an empire? Like looking at the capabilities of AI right now, like what can an umpire do while an AI can have access to every single match ever played? So an AI can be a much better umpire theoretically. So do you think that will ever happen?
Let us talk in MATH.BIZ. So I hope to see you there, because there is no right answer at this point to your question. So I don't want to, spend time on that, but we can discuss that.
Okay. Thank you, sir. Bye.
Thank you. Thank you, Mir. Bye.
Thank you, sir.
Okay.
So I was
Oh,
saying
yes.
the Britishers cracked the German code, but they didn't want to use that code breaking a lot of the time. The reason was, if they used it, they magically bombed every German plane and boat out. The Germans would get suspicious. And if the Germans got suspicious, then they would add extra security to their code. And if they added extra security, then it would be uncrackable. So they decided to not use the code unless it was critical situations, like a major city was about to get bombed.
Exactly. So you should also be careful when not to use the data. Very good, Ayush. Okay, that's it from our end. Adityan, do you have to add anything if I missed something?
No, but thank you very much for the amazing talk. I think it's it began at 5:30 and then it's 7 a.m. in the morning. But the content of the talk, your enthusiasm was nothing like you were sleep deprived. It was like as good as always. So thanks for the amazing talk once again. It was really fantastic.
Thank you everyone. I will share the PowerPoint slide with you all. I don't know if there is a group or something, but you will get the slide deck from our end. So there are some interesting articles that I have mentioned. Adityan has also mentioned one article, so you can read more how data analytics is getting used in cricket. Okay, so I hope to see you all at MATH.BIZ and wish you all the best for the entrance test on April 2nd. Till then, bye from our end.
Bye, sir. Thank you so much.